My name is Dr. Lizeka Samba. My background is in maths education. My PhD was on how we learn mathematics. I'm always keen to do my teaching from the student perspective, focusing on the difficulties and misconceptions. So most of my workshops are going to be based on that. So today we are starting the first class on simple interest and discount. So I'm going to start now taking you through on the simple interest and discount. Those two, they are going hand in hand, because we want to, for you to understand any topic in maths, you need to have something to contrast it with. So now when you've got simple interest, you must understand what are the formulas and how are they different from the discount. So now that's why we are having those two topics today, and we are going to be looking on common examples and also look at the exam equivalent questions to help you to think around them. Now let us start by looking at the simple interest. It's a straightforward topic, but it becomes problematic when you have to answer the exam related questions. Otherwise, it is very straightforward. I will try to take you through the basics, because it's all about getting the basics. Some of us have not done maths for a very long time, and then we find ourselves that we are stuck with it right now. So we'll try and make you remember some of the common aspects that we did sometime from high school. Okay, so now looking at the learning outcomes from this chapter. What is important? It is important to know what is it that you need to know, because some of the chapters, they are carrying too much information that you don't even need. So here, what you need to be aware of, that you need to master at the end, and that's what you're going to be examined at the end in your assignments and also in your exam. It is the basic concepts and application of simple interest and simple discount. Next week, we are going to be combining these two together with a compound interest and get the questions that are combining all of the three aspects. But today, we're only looking at the two. Okay, the critical aspects that you need to be aware and be clear are the definitions. Remember, in any discourse, you need to know what kind of a language that is being used in that discourse. Okay, so the special discourse here is about simple. We are doing a discourse of simple interest and discount. So you need to know what is an interest, is a definition of interest, and then an interest, you can take it from this everyday language. Interest is something that it is accumulating, something positive. Okay, you can even take it from a spiritual or psychological perspective. And interest is a positive feeling, so it's something that is positive, that is accumulating. Okay, then the simple interest, it is the value. Okay, I want you to differentiate, because now the reason why sometimes you find that you don't get through the exam questions is because of the English. Okay, we are all struggling with English. Mina, I remember when I was doing my thesis, I could not in English. I was thinking in Xhosa, and then I could not write in English. So somebody told me that I should write in Xhosa and translate, get a dictionary in English, and then get an academic dictionary. So it's important that you understand the language, the key words, the key concepts. So there's a difference between simple interest and an interest rate. A simple interest is the value. I will take you through the formulas, differentiate those. What is a simple interest? What is an interest rate? Those are two different aspects. Okay, so there is a principal amount and also a present value. Those are the two synonyms. They're synonyms of each other. And then there's a term. I've spoken about an interest rate. There is an amount, an accumulated amount, and there's which is also a future value. And then there's a maturity date. you'll see when we are talking about the maturity date, when we are doing ilento ama bonds. Ama bonds is very important to know the concept of maturity date. It's important to know the timeline. The timeline helps us, those who are struggling with English, to understand the story. Put the story on the timeline so then you can see what happened at which period. So it's important that you know the ins and outs of the timeline. And there's also a simple discount. A simple discount is also an amount, it's a value, okay? And then a discount rate is a rate, it's a percentage. Okay, so make sure you can see those two differences. The reason why I've put these two is because the common misconceptions that we find is when the students are asked to calculate a simple discount, they will calculate a simple a discount rate instead. So make sure you read the question very careful. And then there's a nominal or a face value. Those are the terms that you are going to find when we are working with the bonds later with these workshops. And then there's a number of days. It's important to know how to calculate the number of days in a year, weeks in a year, because that's how we work. We are working with annual returns, not a daily returns. So we want to convert those. And then we've got time value for money. I've got some examples on time value for money, so then you can be able to see when you've got different periods, how do you manipulate the concept of time value for money. Okay, what are the common misconceptions now that we have identified with this concept of simple interest and discount? There's a misconceptions whereby you quickly apply an incorrect formula. Maybe you are panicking, you apply an incorrect formula. What I found very common misconception is when students would apply a formula for simple interest and a discount, a simple discount. I'll show you because I've put those parallel to each other so you can see the difference. And then there's also a problem of substitution. Okay, that is basic mathematics on how to do simple calculations on substituting a correct value in the formula. Not that you don't understand the concept of simple interest, it is just the substitution. Okay, and the main one that now I'm also struggling with, it is the one of translating from word problems to mathematical expressions. Okay, that's why the concept of timeline becomes important, because it is most of the questions are based on word problems. And then there's also an issue of the time, that is months or years. I will take you through what we mean. Sometimes you've got the weeks. Okay, you'd have the weeks. The weeks, there's 52 weeks in a year. If ever you are given the weeks, you need to convert these weeks into an annual time. Okay, so I'll show you how you do that. So those are misconceptions that you find when you are given a question. You are given something in weeks. The context is in weeks. You need to be able to convert those to an equivalent annual time. Okay, so let us hit it off and talk about now the simple interest. We've said now the interest is a price that is paid for a use of a borrowed money. It increases the value. If you have borrowed the money for 100 Rand, and then the interest amount, maybe if it's 10 Rand, that will be an extra amount. Okay, so now we need to be able to contrast this one with the definition of a discount. So what is important? It is know the terms. What is an interest? What is an interest rate? What is a principal and a present value? The term of the loan, the sum accumulated, or the future value. Those are two synonyms of each other. And from these aspects, what we need to know. So you've got these aspects. We need now to relate these by calculating. Okay, so you need to relate the above mentioned terms using the formula for the simple interest and sum accumulated. Okay, we need to be able to calculate. That is what is important. We are calculating any of these variables. Okay, that means the interest. You've got an interest. You've got an interest rate. These are the variables that you find. You've got the present value. You've got the present value, you've got an accumulated amount or the future value. You also have the term. The term will be N, or sometimes you find it which is T. So those are the variables. Talk about variables in mathematics. Okay, so this is what is very important. So if you find that you are struggling with a specific way of calculating, please stop me so then I can take you through, because this is the most basic stuff. Things start to get a little bit interesting when you are doing compound interest. Otherwise, with simple interest, things are like flowing. So if you go and Google on your, you go to internet and Google, you find that the simple interest is given in this formula. Okay, these are the variables that you'd find. Okay, and then another formula that you find this formula, which is an accumulated amount. P is equal to 1 plus RT. It is not in your textbook, but it is like in Google, because some of us don't use only one resource. Okay, you are not only relying on a study guide. It's up to you. If ever the study guide is, you are happy with the information there, then it's okay. But if you want to listen to other people, you can just go and Google. You must know we are talking about one thing. So what is important here when you're talking about simple interest is that the interest rate now, okay, the interest rate is calculated per annum. When we are talking about per annum, we are talking about the year. We know that the year, we've got 12 months in a year, we've got 52 weeks in a year, we've got 365 days in a year. Okay, but everything, if ever the interest rate is expressed for a shorter period, what we mean about the shorter period, we mean maybe if ever it is expressed in months, then the term must be expressed accordingly by dividing. If ever it's the months, if ever the question you are told that the interest is paid monthly, you must know that you need to convert that and divide by 12. Okay, if ever you are told Guti, the interest is paid weekly, you need to divide by 52 because you've got the weekly. And then if ever they are told that the interest is paid daily, you need to divide by 365. Okay, if ever you are told that the interest is paid over 2 years, 2 years, it is just years. So if years, you are happy, you don't need to convert anything. Okay, it's only when you've got these ones. Okay, so that is very important to keep in mind. Okay, so now there is, remember we said there is a simple interest, there is also a simple interest rate. There's also an interest rate. Okay, so a simple interest is the value. Okay, this is a very important formula that you will find throughout this course. You'll see that when we are doing amortization, we are going to be referring to this formula. Okay, this is the formula that you use when you want to calculate the value. If you've got these variables, look the variables that are given, and then if you are asked to calculate the value, that is the simple interest, you would use this formula. However, not always that you are going to be given all of those variables. Here is another formula. This is a very also critical formula that you find that is defining ilento simple interest. The S is for your future value. This is for your future value or the accumulated amount. Sometimes you find the text are talking about accumulated value. Okay, and then you've got this P. This P, you sometimes find that some of the questions you are talking about the amount that you invest now. You must read that English. principal, it is a present value. That is the present tense. Okay, it's a present value we're talking about now. So it's important now you are aware of the time value for money. And then you've got your R. Your R is your interest rate. This is your interest rate. And then here you've got your T. Your T will be equal to the time of your investment. This time of your investment, it needs to be annual, but sometimes if you find it that is not annual, you need to convert it. Okay, you would have to convert it. If it's weeks, you convert it to annual by dividing by 52 weeks, and so on and so on. You'll see that when we are doing some of the examples. So this is just the summary. Okay, this is the summary of that whole chapter about simple interest. Okay, we'll come and talk about the discount. Otherwise, if there's anything that you want to know about simple interest, this is what you need. You need to know about this formula. So there are different formula that you need to be aware of that you can use. Let's see how we manipulate these formulas. Okay, so here's a simple a question. Why I want to take you through slowly on these questions is to help you to get into a routine on how to read these questions. Okay, so now you need to break down the question step by step and write all the information that is given step by step. Here you are asked to do something. Okay, what is it that you need to do? You are required to can you see? You are required to calculate a simple interest, not a rate, ne? You are required to calculate simple interest quickly in your mind. You know the simple interest, it is that I from the formulas. You are required to calculate the simple interest. Okay? So, and also you are required to the sum accumulated. Remember, what is the sum accumulated from the formula? The sum accumulated, it is S. Okay, so now you're already aware of what you are required to calculate for. Okay, this is for this is for 5,000 borrowed for 90 days. So this 5,000, it is a principal amount. So now your P is equal to, that is your present value. It is 5,000. It is borrowed for 90 days. Okay, look at your time here. Your time is in days. And then remember, we said if ever your time is not annual, you need to divide. We know what in a year, you've got 365. You've got 365 days. So you are dividing because it's days. At a simple interest rate here, you are given a simple interest rate. So your simple interest rate here is equal to 15. That is 0,15. Okay, so now here you've broken down everything that you need. And now the formula that you would use here, you would get the formula because now there are different formulas that are there for you. Let's look. You've got different formulas. You are looking for the accumulated amount. Okay, you are looking for this amount. You are also looking for this amount. Okay, so now it is the simple interest, and also you are looking for the accumulated. So now you are looking for these two. You want to use these two formulas. Okay, so now let us first get our the one for the interest. We are looking for the interest. That's what we are looking for. We are also looking for the sum accumulated. We are given the sum that is borrowed. That is the present value. The present value is 5,000. And then we are told that our time is equal to, our time is 90. And then we said we are going to divide that by number of days. Okay, by number of days, which is 365. Why? It's because we are working with the days. And then the simple interest rate, we are told the simple interest rate is 15%. Okay, So we said we are going to start with a formula. I is equal to PRT. So now our P, it is 5,000. Okay. Our R, it is 0.15. And then our time is already been converted. So we are going to be having 90 divided by 365. And then you can just plug this thing into your calculator. And then in your calculator, you find that the simple, in the interest that they are looking for, that means this first part, it is 184. It is 184,93. Okay, so now that is the first part that they are looking for. So from here, you can find your accumulated amount. Okay, so now there are many ways of calculating the accumulated amount. Remember from our formulas, you've got this formula, which is saying your accumulated amount, it is P plus I. So now you can use that. So now you know that your accumulated amount, it is P plus I from your formulas. Okay, so now your P, you've already have your P. Your P is 5,000. And then the interest is what you've just calculated. Okay, it is 184. It is 184,93. So your accumulated amount, it is 5,000. 5,184,93. So that is your accumulated amount that that you can calculate. But there is another way whereby you can calculate the accumulated amount. Maybe you don't don't like this formula. You can use a longer method. Let me get another different pen. Let's use this one. Remember, there's another formula which is saying your S is equal to your P into 1 plus RT. This is yet another formula to calculate your accumulated amount. You know that your present value, your principal is your 5,000 into 1 plus your R. There is your R, it's 0.15. And then the time you use the same variables as you've broken them down. This is 90 over 365. So you plug this thing into your calculator, you find that your accumulated amount is 5,184,93. Okay, so this is yet another way of calculating. So you don't need to be stressing and say, I don't know the other method. So it's either you can use this one or you can use that one. Okay, so now those are the two different methods of calculating the accumulated amount. Let's look for another question. Okay, so now here this question is saying now we need to determine the present value. So the present value of a loan, they say determine the present value of the loan. So now this is, I mean, straightforward. You are asked to calculate the present value of the loan that is issued today. Okay, it is issued today, so now it is a present value with a maturity value that is the future value. Remember, when your investment matures, okay, there's a common misconceptions that you find with the way that the simple interest is defined. It is defined as if it's only working on the amount that is borrowed. It can also be an amount that you have invested. Okay, it can be amount that you've borrowed or invested. So be careful. You must not only think that the simple interest or the compound interest is only for the money that you borrow. It is also for the money that you have invested. Okay, so you are told here the future value. So now this is straightforward. You are told the future value. Remember from our formulas, I want to use the variables that are similar to our formulas. So now we are told that our future value, it is 12,000, and then in 2 years time, this is the year. Okay, so now our time is equal to 2. We don't need to be worrying about converting anything because our time is given in years. It's not given in days or weeks or months. It is years. So we don't need to convert anything because it's already an annual the time is an annual timing. So now we leave t as equal to 2. And then here, this is simple. You are told what the simple interest rate you are told it is 0.12. Okay, is applicable. What is it that you are looking for? You are looking for the present value. So this one is one of those straightforward questions. So now you know the formula. Always get your formula. Your formula is S is equal to 1 plus RT. So you're looking for the what is it? You are looking for the present value. Okay, so now that means you are looking for this value. It is always advisable to make what you are looking for a subject of the formula. Okay, so now we can make our P to be equal to S over 1 plus RT. Okay, by making P a subject of the formula. So what is your accumulated amount? There is your accumulated amount. It is 12,000 divided by 1 plus our R there. It is 0.12. And then this thing is into the time is just equal to 2. Okay, so this one, you can just plug it into your calculator and then you will get that your present value, it is equal to 9,677 rand, 62. Okay, this one, it is just, remember what are the learning outcomes? The learning outcomes are saying you'll be given variables, so we need to work around the formula and solve for one of the variables that are not known. That we are talking about solving for an unknown, that is algebraic procedure. Okay, this is just to remind you of the basic mathematics in case you've forgotten. Okay, here is another example. Okay, let's say Jojo deposits 30,000 into a bank account. So now when is he depositing this amount? Now, look at the English, present tense. Deposits. Sometimes the question will not tell you when is this person doing this thing. It's all about reading the simple English that is embedded in the story, the context. So now Jojo deposits, that means this term deposits, there's a present tense. We're talking about English now. Deposits, it means now this is your present value of 30,000. Okay, into a bank account that pays a simple interest rate. You are told that the interest rate is equal to 0.075. Let me highlight one of the misconceptions that you find on these. Be careful of that. So you can simply say, as some people write that the conversion of this is this. Okay, which is incorrect. Okay, so if maybe you are not sure, because sometimes it's not that you don't know these things, it's like you are so used to say, if ever I've got a 15%, that is 0.15. So if you are not sure, take that the amount that is given for your percentage, divide it by 100. So take 7.5, divide it by 100, so you will get the correct value, which is this one. Okay, so this will be the correct conversion of 7.5. So I am highlighting the common misconceptions here. Okay, things that will just make things go wrong in your calculations. Not that you don't understand the procedure. It is just those common misconceptions. So now you are asked how many years. You are asked to calculate the years he must invest. Who generates the simple English? To generate is something that is going to happen in the future. So now this becomes our future value, which is our S, which is 45,000. So because you know what this is a simple interest, what you do, you just go and pull out the simple interest formula. So the simple interest formula, it is saying you've got P into 1 plus RT. That's your simple interest formula. Okay, so you are already given your S there. Your accumulated amount, it is 45,000. Your present value, you are told what it is 30,000 into 1 plus what is your R? There is your R. Okay. I want to sensitize you to this notion of misconceptions. You'd find that I'm spending too much time highlighting those little nyana things that can make things go wrong. Okay, so now every time when I'm doing an example, I am highlighting a common misconception that we normally find in these kind of calculations. So here, your rate, it is 0,075, and then this is multiplied by your time. It is what you are looking for. Remember, the question is saying find your time. Okay, so now we want to make the time. So here, the simple mathematical calculation, you would divide both sides by 30,000. This is going to be 1 plus that, you are going to have 1 plus 0,075 t. Okay, so this implies that, okay, this implies that 45,000 divided by 30,000, it is 1,5, okay, which is equal to 1 plus 0, we've got 1,5, 1,5 minus 1. So now you just simplify. So you find that, let me do this thing in case there are some who have forgotten how we do this. So this is going to be 0,075 t, 1,5 minus 1. You find that it's going to give you 0,5. Then you divide by 0, normally I don't go through these steps. I'm just doing because some of us really have forgotten these things. So I'm just doing this thing step by step. So I don't normally do this. So T is just going to be equal to 6,67. Okay. So now that is the time that they are looking for. Okay. Let us look at another example. Okay. This example is asking Guti, at what interest rate should Lala invest if she wants to grow? This is like straightforward. This is from, that means your present value is equal to 2,500. Okay, okay, so this becomes your S, which is equal to 4,000. Okay, so your T there is equal to 5. What is it that you are asked to find? You are asked to find the interest rate. So we need to see how we calculate the different variables in a formula. So you know that your S is equal to P into 1 plus RT. Okay, so you can just substitute everything into your formula. Your S there is 4,000. Which is equal to your present value, it is 2,500. Okay, which is 1 plus your rate is what you are looking for. Your time, okay, because your time is in years, you don't need to be dividing by anything because it's annual. It's an annual, the rate is annual, it's paid annually. So now you don't need to worry about dividing your time by 52 weeks or whatever. It is annual. So now your time there is 5, so you're going to have your 5. Okay, so now you rearrange everything same. I think it's similar as the previous one. So I'm going to be dividing by this, which is equal to 1 plus 5R. I am not really going to go through each and every step here. Okay, I'm not going to go through each and every step. So this is going to give you 1,6, which is going to be 1 plus 5R. This is simply algebraic calculation. So your R there your R is going to be equal to 0.12, which implies that your R is equal to 12%. 12% is when you multiply this by 100. Okay, so now this is a basic example. So let us look on this one. Okay, the one which has got some meatinyana or some English. Okay, so now the story goes like when his son was 6 years old, that is then, we are looking at the time value for money here. This is 6 years old. That is when Metuli made a deposit. Okay, so Metuli made a deposit 6 years when his son was 6 years old. You are looking at his son here. He was 6 years old. That means this is your T0. T0 was 6. This son was 6 years, and then he made a deposit. That was your principal value. That's an amount that he made, the initial amount at T0. Okay, so now at T0, now we are going to be also drawing this thing in a timeline. You've got your T0, and then he made a deposit in a bank account. So this is your P. Your P is 6,610. The investment grew at a simple interest rate. There is a simple interest rate. We know already in your mind, you know the kind of a formula that you are going to get, because the context is self-explanatory. It tells you the formula that you need to use. Okay, when Metuli's son was 18 years old, so now this is TN. Okay, TN is 118. That means the final time of maturing of this investment. The value of the investment was, okay, this is the future. So now this is an accumulated amount. Remember, the English that is being used here to refer to the accumulated amount, it is a value of the future value or the accumulated amount. It is 11,131.24. At what rate was the money invested? So now at what rate? That means they are looking for an interest rate. So now you can draw this thing in a timeline. Timelines, I like them because they help you to see what is happening there. So now at your T0 or at your T1, this is your T1, which is equal to 6. Okay, and then your TN there is equal to 18. Okay, can you see now, Gucci, you've got the son, the investment started when the son was 6 years, and then it matured when he was 18. You need to know how long was this investment, the time. Okay, to get the time of this investment, you're simply going to say 18 minus 6. So then you can get the time of this investment. We are not interested on Metuli's son age. We just want to know how long was this thing invested. Okay, he was there to just to give us a measure. We need somebody to help us to measure the time, but we are not interested about how old. He's old now. He's 18 years old. We just want to understand the length of the investment. So the length of the investment, it matured when he was 18, and then it was invested when he was 6. So now we want to know how long the investment took place. The investment was 12 years. Only the investment, not his years. Okay, so now what is it that you're looking for? This is T0. This is your present value. It's always happening when you are starting with your investment, which is 6,010. So now it has accumulated. That is your S, which is equal to 11,131.24. Okay, we are looking for what? For your R. So now here is the timeline. Okay, it helps us to think around around these around the formulas. Let's get the formula now. We've got the context, we have decontextualized it and put it into a timeline. Let us get the formula. So the formula for the simple interest, it is equal to P into 1 plus RT. Remember, this is a simple interest rate formula, a calculation. So your S there, your S is 11131.24. What is your present value? The present value that was invested is 6610 into 1 plus, you don't know your R, that's what you are looking for. The time, you've calculated the time. Okay, so your time there is 12. Okay, so you can just do the calculation as we've done on the previous one, making R the subject of the formula. So now here you can have 11131. I'm going to be doing this thing so then I can help those who have done their maths 2009 to remember how this thing was done. So from here, you can just plug into your calculator. You'd find that your R is equal to 0,057, which is equal to 5,7. That is your interest rate that they are looking for. Okay, so now that is a question that is helping us to think around the timeline. Always put things in your timeline. The more we are going to be doing these examples, you will see when we get to compound interest, writing things down into a timeline, it is helpful to see if ever there's any change of an interest rate at some point. Okay, so now here is the timeline of a simple interest. You'll find it in your notes. Okay, I've just put it here for a timeline so then you know how to write every time. Write down the story. Write down the story on your timeline. So that is basically our simple interest formula. Okay, so now let us come and get to the simple discount, you know. So now here is the simple discount. So now I've taken you through slowly on the simple interest, how we think around it. So now I'll take you through the simple discount and then take you through on how we combine these two in one question. The simple discount, the learning outcomes about this section on simple discount is for us to be able to differentiate between a discount and a discount rate. Okay, and also look at these keywords, a discounted or a present value. When you look on the context on the story, you're asked to calculate the discounted value. That is the present value. Okay. The face of the future value, that is the value that you are going to be focusing on the future. That is an accumulated amount. And then there's a term, that is the time. Okay, so now what is it that we need to know is to interpret the formula and also translate these stories into a timeline. Those are the learning outcomes. So the interest on the future value, okay, that's a definition of simple discount. The interest is calculated on the future value of a term and paid at the beginning of a term. This one is called the discount. Okay, so now the discount is calculated on the future value at the simple interest rate. Remember the simple interest, you were calculating this thing on the present value. The rate is calculated on the present value. Remember the simple interest. So this rate is calculated on the present value. Here, the interest is calculated on the future value. Let us look at the formula so then we can see the difference between these. Okay. I've put these things parallel to each other to help us see the difference. Okay, because these are working the same way, but it's just the keywords. Okay, the simple discount, it is calculated on the future value. Okay, the simple interest, it is calculated on the principal or the on the principal value or the present value. This one is calculated on the future value. So that's how they are different. Okay, so now here are the formulas. Remember, we said there is a discount, okay, which is a value, okay, we've got the value, okay? And then if you compare this along the simple interest, this is the formula for the discount. This is the formula for the interest. I'm not talking about the rate, but I'm talking about the interest and the discount. Okay, D is the simple discount. It's an amount. Ne? It's an amount, not the rate. Here, I is the simple interest. It is an amount and not the rate. So now you must see the difference between those two. Okay, so here, when you are looking at the two, you've got now, if ever you are looking for an interest, here's another formula. So I've done the comparison along with the simple discount, so then you can be able to see the difference. You don't confuse them. And then you've got the discount rate, which is a small a variable that is a discount rate. You've got R, which is an interest rate percentage. And here you've got the sum accumulated of the future value, okay? And then here you've got the principal present value, which are these. So I've done this thing along each other, okay? So you've got the time in years is the same, and the time in years. We are still applying the same principle, okay? We are applying the same principle of if your time is less than a year. If ever it's weeks, you divide by number of weeks. If ever it's monthly, you're going to divide by 12. Okay, so here are the formulas. So now here's a formula for the discount. Look at this formula and then compare it with the formula of the simple interest rate. Okay, can you see the difference? The one for simple interest, we said it is calculated on the present value. This one, the interest, which is the discount, it is calculated on the future value. So make sure that you can see the comparison between the two. And then here is the formula. I've just put this formula so then you can see the future value is the same as the S, okay? The present value is the same as the P on the simple interest. Sometimes you find that the text is talking about accumulated amount. Accumulated amount is the same as your S or your future value, and then your P is your present value. So I'm just putting these different kinds of formulas that you'd find. So here is the formula. This is the same formula as this one, but it's written in a different way. Okay, this is the same formula. They are similar. I've just written them so then you can see that you can rewrite them, and the way that the context is put in different ways. Maybe you've got an accumulated amount or you've got the future value. Okay, so now see these formulas parallel to each other. So now we are looking at a simple discount and also on the simple interest. These two can be combined, okay? Can be combined. You can get if you've got a discount rate, you can calculate for an equivalent interest rate, okay? So you've got a discounted discount rate and an interest rate. So one, you can get the discounted interest rate, okay? So now this is the formula. If you are given a discount rate, you can calculate an interest rate. R is for an interest rate. If you are given a discounted rate, you can calculate for an interest rate. So we are talking about equivalent rates. Okay, so now these are the formulas that you need to keep in mind. You don't need to derive this formula. You just have to know. Just remember, if you remember one, you don't have to know this one. This one can be, you can just get it from this one, okay? You do have it on your formula sheet. So now this is a formula for equivalent interest rate and discount. It's discount rate against the interest rate. So now let us look at the examples. Okay, so now here is a question which is saying we need to determine the simple discount. Okay, The formula is saying we need to calculate the simple discount on a loan. Look at the question. It is looking for the simple discount and not the rate. So the simple discount will be a big D. Okay. So remember, there is a small d, which is a percentage, and then there is a big D, which is an amount. Okay. On a loan, this is on a loan due or in 8 months. Remember, a discount is calculated on a future value. So now a simple discount on a loan of 8,000 of 3,000 due in 8 months. You can just see, Guti, this amount is due in 8 months. It is in the future. So now this one becomes your future value. Okay, it is due in 8 months, so your time there, it is 8, but remember, it is in months. You need to convert. That means you need to divide by 12. Okay, at a discount rate, you are told that the discount rate is equal to 0.15. I'm converting with 15%. Okay, and dividing it by 100. 15 divided by 100, it is 0.15. What is the discounted value? Okay, remember what we said here, a discounted value. We said we've got different ways of naming these things. We said a discounted value is the same as the present value. I'm just throwing here different ways of how these things are named, so then you don't get confused. A discounted value is the same as the present value. Okay, so now here you are asked for a discounted value. That means we are looking for our P. Okay, that's what we are looking for. And also we are asked for an equivalent interest rate. So now once you see a word equivalent interest rate, we know that this is the formula that we are going to be using. Okay, this is the formula for an equivalent interest rate against the discount. So now there are two things here that we are going to be looking. So now let us go and calculate our D. Okay, the formula for our D, here is the formula for our D. Okay, so now we come here and say the discounted amount. We are looking for an amount, not a discounted rate, because the discounted rate is given. Our D is equal to SDT. Our S, there is our S is 3,000. You've got 3,000. Our discounted rate, it is 0.15. And our T, remember, our T, we needed to convert because it is less than a year. So now you've got 8 divided by 12. Okay, so now you just plug this thing into your calculator. So your discounted amount is equal to 300. Okay, so now the question is saying now you want to get what is an equivalent simple interest rate. Okay, you are looking for a simple interest rate equivalent. So now you know that there's a formula which is R is equal to D over 1 minus dt. Okay, you are looking for this R. That's what they are looking for. So now this discount, this implies that your R is equal to, what is your discount? It is 0.15. You've got your 0.15. 1 minus, what is your D? It is 0.15. And then what is your T? Your T, it is 8 over 12. Okay, you are using this formula. Then your R there is going to be equal to 16.67. Okay, that is your equivalent simple interest rate. So when you are given a discount and then you are looking for an interest rate, this is the formula that you will always use. So now this is a simple interest rate that is equivalent to a discounted amount, discounted rate of 15%. So now we've calculated two things here. We've got, what is it that we were asked? We were asked to find, determine the simple discount. Okay, we have calculated a simple discount. Okay, here is it. And we're also asked to calculate the simple interest. Here is it. We still need to calculate our P. Okay, So now how do we calculate our P? You go back to your formula sheet, okay? To go back to your formula sheet, there is the formula that you would use. Okay, so now you go to get the formula to calculate for your P. I'm going to write it here. So your P is equal to S minus D. So what is your S? Your S is equal to 3,000. And then your discounted amount, it is equal to 300. So therefore your present value is going to be equal to 2,700. Okay, so now that is the simple discount. And then we have combined it a little bit with some simple interest and look for an equivalent simple interest rate. Let us look on another example to see how many I have. I want to finish everything. Okay, so let us look on this example. Okay, a loan of 4,000 must be paid in 6 months. In 6 months' time. Okay, so now you can see what this is something that needs to be paid in 6 months' time. Already is telling you this is your future value because it needs to be paid in 6 months' time. So now in 6 months' time, so now your time here is equal to 6. Remember, this is a month, so now you can just divide by 12. Determine the amount of money that you will receive now. Okay, the amount that you will receive now. So that means you are asked to find your present value. If a simple discount is 18% per annum, so now your R is equal to 0.18 is applicable. And also determine the equivalent. Okay, this I'm making a mistake here. So this is a discount rate. And also you are asked to determine a simple interest rate. We don't know this thing. Okay, so now here you can just get your formula. Okay, your formula, this example is similar to the one that we have done previously. So now you've got your D. Your D is equal to S DT. Okay, so now this is going to be equal to 4,000. Your discount rate, it is 0.18, and your time is 6/12. Okay, so your discount there is going to be equal to 360. Okay, remember you want to calculate your P here. So now your P is equal to S minus D, and then your S there is equal to 4,000 minus your D. Our D is equal to 360, which is equal to 3,640. Okay, so now that is your P. So now you've got everything here. So you want to calculate for your equivalent rate. So you can use the formula. Your R is equal to D over 1 minus dt. Okay, I'm not going to go through the formula. You can just plug everything here to get your R. Okay, because this example is similar to the previous one. I need to cover all of these examples that I've chosen to do today. This is also another example that I'm not going to calculate step by step. Let us look on the first question. Determine the simple interest rate that is equivalent to a discount. You know what is the formula? The formula is R is equal to D over 1 minus dt. Okay, so now for the first one, you've got your R is your D. Okay, here you are told what this is a discount rate that you are given. So your D here is equal to 0.12. Okay, and then your time is 3 months. That means if it's 3 months, you need to divide by 12 because it's months. Okay, here your D is equal to 0.12, and then your time is equal to 9. Because it is months, you need to divide by 12. So you use this formula. I'm not going to go through the actual calculation. What I've done here is to break down the given information and put it into variables, okay, in a mathematical term. So I'm not going to be doing the calculations themselves, okay? So let us look, let us look on further examples. I've picked up some exam equivalent questions to help you to see how these questions are asked in an exam context. So here, Nola invest 1,000 in an account earning this simple interest. The balance in the account 6 months later will equal to. Okay, so now I'm going to pull this thing into smaller pieces so then you can plug it into your formula. So now Nola invests, look at the English, invests, that means now your present value is equal to 1,000. This is a present tense. Okay, in an account earning a simple this is a rate of 0,0657. Once again, be careful of this. Don't convert this thing into 0,657. That is an error. Okay, you convert this thing as 0,0657. And then this is a simple interest. You already know that you're going to be using a simple interest formula. And then the balance in the account, look at the time. The time is given in months. Okay, so now once the thing is given in not in years, you take that 16 and then you divide it by months. Okay, which is 16 over 12. So now what you do here, you know what is your formula? Your formula is going to be equal to S is equal to P plus RT. Okay, so your S, that's what you are looking for. You must write what you are looking for. So then in case you are asked to find so many things, so now it's important that you write it down. I know that I'm looking for my S. So now your P, have I written this thing correctly? No. So I've got my P into 1 plus RT. So now I'm looking for my S. My P is 1,500 into 1 plus my R is 0,0657 multiplied by the time. The time is 16 over 12. Okay, you just plug this thing into your calculator. You'll find that your answer is 1631,40. Okay, this is somehow straightforward. Let us look at this one and see if ever there's anything interesting about it. A bank discount rate, already you know what you are thinking of a discount formulas. A discount rate is equal to 12%, which is 0,12. You need to pay the bank 5,000 in 6 months' time. This is an amount that you need to pay in 6 months' time. That means in the future. So now your S is equal to 5,000. When do you need to pay this one? You need to pay it in 6 months' time. You've got 6 because it's the months you divide by 12. If it was 6 years, you don't divide it by anything. You take the years as they are. The amount of the money that you will receive now from the bank, you are looking for your present value. So because this is a simple discount formula, you need to go and get the correct formula for a simple discount. So now the simple discount formula, let us look at the simple discount formula. The simple discount formula, it is P is equal to S1 minus DT. It is different from this one. Ne? It is different from this one. Okay, so now to get that formula, we are going to say we are having P is equal to S into 1 minus DT. Okay, this is the correct formula. What is a common misconception that I want to highlight to you that we find on questions like this? Questions like this, you find that people would go and write the formula like this. Okay, this is incorrect. Okay, why people are thinking of the simple interest and write this formula, because they think, okay, if I've written this one, this is the same as the simple interest. It is not the same. Those are totally different. So make sure that you are using the correct formula. I'm not going to do the substitution. I just wanted to highlight the common misconception that we found. That's what I wanted to highlight. Be careful, use the correct formula. Okay, let us come to another example and see what is it that is being suggested here. Here, the question, let's see, the investment of 20,000 accumulated to, okay? So this is an investment that has accumulated. So now this is your future value. This one is your present value, okay? If the applicable simple interest is 12%, so this is a simple interest formula. So your R is equal to 12%. Then the time, so you are asked to find the time here. But you know, Gucci, your simple interest, you are told, Gucci, this is a simple interest. So you get your simple interest formula. So your simple interest formula, it is this one, 1 plus RT. Okay, substitute the variables accordingly. So your S, you've already identified it. It is 45, 200. Your P, you have identified, it is 20,000. So you are doing the analysis. We call it a global approach when we are analyzing what is it that is given. So you've got 1 plus your R there. It is 0,12. You don't know your T. So you can just play around with this, and then you find that your T is going to be equal to 10,5 after you have done the calculations. Let's say you forgot how you do the calculations. You divide by 20,000, which is going to be equal to 1 plus 0,12 T. Okay, you find that your T is 10,5. Okay, let us look on another example. Okay, this example, you are saying if the simple interest rate of 24 is equivalent to a simple discount. So now you've got that equivalent situation. You've got 0,24 and the simple discount is equal to 0,25. Okay, then the time under consideration, you are asked to find time. So the minute you see equivalent, you've got interest rate and the simple discount, you know that you are going to need to use this formula, d over 1 minus dt. Okay, so you can just substitute. Okay, so your R is 0,24. Your discount rate, it is 0,205. You divide by 1 minus your D, it's 0,205. What is your T? That's what you are looking for. How do you simplify? You can just cross multiply. Okay, we cross multiplying, it means you're going to have 0,24 multiplied by what is in your denominator there, 1 minus 0,205 T. So this one, it is just going to be equal to 0,205. Okay, so now you are going to do what we call distributive law. So you are going to have 0,24, whereby you multiply this by that and multiply this by that. We call it distributive property. So you are going to have negative 0,0492 T. Okay, is equal to 0,205. Okay, so here you can just rearrange everything. Okay, rearranging everything, that means you are going to have your 0,0492 T is going to be equal to 0.24 minus 0.205. Okay, so now you do all your calculations. This one minus this, you get an answer, and then you'll get that your T is going to be equal to 0.711. Okay, and then you get worried and say, I don't have 0.711 in all of these options, However, this is just a unit that needs to be multiplied. Your multiple choice questions are given in days. That means whatever unit that you have received here, you need to multiply it by the number of days. How many years in a year it is, how many days it is 365. So now we are going to take this unit of 0.711 multiplied by 365. Okay, then you are going to get that you are going to have 260 days. A question may be asked, what if here I had 260 weeks? I'm just making an example. If this was weeks, you are going to take this unit, okay, multiply it by 52 weeks, okay? It will depend on what are the measurements here of your days. Is it days? Is it weeks? Whatever it is, you are going to multiply and get 365. Okay, this is going to guide you. All right. So let us look on let's see if ever this example. Okay, I want to look at this example. This example, the reason why I want to look at it, I want to, because now you are given the date, okay? So Gina invested this amount, okay? She invested this amount, that is your present value, okay? This is your T0 on 5th of March. So this is your T0 in an account earning 8,0. So now your R is equal to 0,0876. You notice a simple interest is per year, okay? The accumulated interest on 15th of November, the accumulated interest, you are asked to find your I. Okay, so now this is your TN, okay, will be equal to, so you need a timeline here, okay? This is your T0. Your T0 is equal to 5th of March. And then your TN is equal to 15th of November. Okay, so you are asked to find the accumulated interest, that is your I, okay? You are given all of these things, okay? For you to be able to calculate for your interest, you can calculate your interest by getting what, there are many formulas for an interest. You've got this one, which is saying, let's go back. Can I go back? I want to go back. I want to go back to our formulas, okay? Here is a formula for an interest. It is PRT, okay? You can use that formula to calculate, okay? You need your present value, you need your interest rate, and then you also need your T. If it's not working, you can also use this formula, okay? Let's see which one we can use, okay? You've got your I is equal to PRT, okay? You've got your P is 25,000. You've got your R, it is 8,76. The time, you are only given the dates, okay? So now remember on the previous, there's an example whereby about that guy who invested money when the sun was so many years. So now you need to calculate the number of days between you need to calculate the number of days between 15th of November, okay? You need to calculate the number of days, ne? So your TN, let me get a different pen. So now you need to calculate your T. Your T is going to be equal to Tn minus T0. So now you need to calculate how many days between E5 is November and the 15th of November. Okay, so now what you can do is to say, I know E15 is November, use that calendar that is given. Let me go to the calendar which is on your notes. Okay, you go to this calendar. 15th of November, here is the 15th, and then you go to 15th of November. The day is the 15th, so you've got 319 days. So you write your 319 next to the 15th of November, and then you look for E5 is March. 5th of March, you go to 5th of March. There is your March, this is your March. It is 64 days. So now we are going to write 64 next to 6th of March, and then you go back to your calculation. So this is at the end of your notes, page 233. You'll find the calendar, which is going to give you the number of days without going any outside to go and do the calculations. So the 15th of November, it is 319, okay, minus 5th of March. You've got 5th of March. 5th of March, we have calculated, the table is telling us it is 64 days. So to get the time, you say 319 minus 64. So you've got 319 minus 64. This is going to give you 255 days. So now your T is 255. Okay, so now once you've got your T, you are going to come into your formula sheet and say, I know what is my P. My P is given as 25,000. My interest rate, it is 0.0876. And then my time, I've just converted my time. My time is 255. Okay, so now the interest that I am looking for, it is 1,530. Okay, so is that correct? Oh, look at the time, ne? Another thing, ne, guys. This is 255 days, ne? So remember, when you've got days, you still need to divide that by 365, so then you can make it an annual time. Ne? So remember, when you've got the days, so you are going to divide this thing by 365. Is that clear? Our days, this thing is in days. Remember the conversion that we've been making. If ever you've got the time that is given in days, you need to divide that by the number of days in a year. Hence, you have to divide by 365. Okay, so make sure that you are always doing that. It is going to be very critical when we are doing the bonds. The bonds we are going to be calculating in days, so we need to know how to convert. So now that's how you will get your 1,530. Okay, let us do another one. Okay, so now let me see how tough is this one, because I'm looking at the time. So I'll just break this thing down so then you can see how we think around this. So now Aziza, this is the amount that he needs. He needs it now. This is the present tense. This is how this guy is feeling, present tense. He needs this amount, 10,000. That means this is your present value. Okay, he is needing it. Here is a present tense, needs. It's not that he will. He needs it now. Okay. The bank agrees to give her this amount now. to be paid in 7 months, okay? The time here is given in 7 months. So you're going to have 7 divided by 12. That is the number of months in a year. Based on the best discount rate, so the discount rate is equal to 0.164. The amount that she will have to pay back, okay? She needs to pay back this amount, which in the future, okay? So you need to get the formula, which is P is equal to S into 1 minus dt. Because I have broken things down, you can substitute everything here. So what was important is to be able to read the context. Okay, once you start getting used on how to read the context, it makes your life very easy. Okay, here is the question, which is it's like we are re-emphasizing on what I've just done. Okay, so what was the present value of the loan? Okay, here you are asked to calculate for your P. So your P, you need to find your P here. On 5th of May, if it accumulates to 5,000, this is your future value. Okay, on the 16th of August, this is the future time of the same year if the simple interest rate is 15%. So this is a simple interest. Okay, so now your R is equal to 0.15. You can get your time. Okay, so now here you've got here, you can get your timeline. Okay, your timeline, you've got your T0, which is happening when? It is happening on the 5th of May. So your TN, the time of your final day of your investment, it is 16th of August. Okay, so now this is your future value on this time, which is 4,500. Okay, and then you don't know what was the amount here. You don't know what is an amount here. Okay, you are given all of this information. For the simple interest, you know what your simple interest is written like this. It is P into 1 plus RT. Okay, you have your S, you don't know your P, that's what you're looking for. You know your R is given, your T is given, but it's not explicitly given. Okay, so now for you to calculate your T, you are going to have your T. Okay, your T is going to be equal to whatever is happening on 16th of August. Okay, 16th of August minus 5th of May. Okay, so now go to your table and get what is the amount of days on 6th of August. You go to your 6th of August. There is your 6th. There is your August. It is 218. Okay, it is 218. And also you are also looking for 5th of May. There is your 5th. There is your May. It's 125. Okay, so now you are looking on these days. Okay, so now you go and write them into your thing. 6th of August, according to that calendar sheet, 6th of August is got 228 days. Okay, and then 5th of days, according to our formula, it is 103 days. So now this is going to be equal to 228 minus 103. It is 125. No? This is going to be equal to 125. Right? Am I correct? 6th of August, let me go and confirm. You've got 6th of August, which is 218. No? It's 218. I'm sorry, guys. That is 218. This is 218. 218 minus 103. Let me see how much I get this side. I've got 218 minus 103. This is going to be equal to 1 115. Okay, so this is going to be equal to 115. Okay, I hope I've got that correctly. Let me check this side. 10, 5, 9. Oh, I forgot my password now. 10, 8, 5, 9. Hashtag. Okay. So this is number 2. So you've got 228. 16th of August. Kantimina, where am I getting this thing? Guys, you're not even helping me here. We are looking for 16th of August. Let us go to the table. 16th of August, it is 228. Hey, it is 228. So now 16th of August is not 60, it is 16th. 16th of August is 228. Okay. 5th of May, it is 125. Is it 5th of May? This is 5th of May, it is 125. Let's go and confirm. You've got 5th of May, there it is 125. Okay, I am sorry for that, guys. So this is 125. So this is going to be 228 minus 125. So that is going to give you 103. Okay, so now you've got your things. So remember, this is in days. For you to be able to manipulate this T, you need to divide this thing in 365. Don't forget to divide. Okay, so now you go and plug this thing into your calculator, your formula first. Né? So you've got your P into 1 plus your R is 0,15, your T. Okay, your T is 103 divided by 365. Okay, your S then it is 4,500. You can just manipulate your formula. You'll find that your P is going to give you 4,317. 26. Okay, so now this is using that calendar thing. So let me see what else do I have here. Okay, I just want to quickly take you through this one of the time value for money. Okay, so now the one for time value for money is applying the timeline. That's why I've chosen this one, because we want to apply the time value. Let us look this one and apply the timeline. The minute the question becomes complicated, apply the timeline. Joseph borrowed 500 2 months ago. This is time value for money. 2 months ago, and 700 4 months ago. This suggests that we are sitting somewhere in the now, in the present. You are here in the now. Okay, we are here in the now. Position yourself accordingly. You are here in the now, and then 2 months ago from now, 2 months ago, this is 2 months ago. Yeah? 2 months from the now, that is previous, this guy borrowed 500. Okay? From the now, 7 months ago, once you've got this thing in your timeline, you can never go wrong. We are here. This is where we are standing, looking ago. So now we are looking from 4 months ago. So now you've got 4 months here. Okay, how much? It was 700. So there's 2 months here. There's two amounts that this guy has made. Okay, so now he has made these 2 amounts with reference to now. Now he wants to liquidate this obligation with a single payment. Yeah, now okay, I want to do this thing in 12 months in the future. I am here now, but I want to pay these things in 12 months in the future. So now all these amounts, he wants to pay them in the future in 12 months. So now he wants to pay these 2 in 12 months. Okay, so with reference to 2 months to here. Okay, so now you are going to be calculating 2 two formulas here, and then you are using here, so he wants to do this thing 12 months from now, from here to 12 months. So he wants to be paying these back. Ne? So if the simple interest rate is 11%, so now your R is equal to 11%. Remember, we said we are going to be working with a decimal. So this is 0.11 is charged on all amounts. So this amount is charged, this amount, this percentage, the amount that he will pay in 12 months. We want to know who to patala malin here. This is what we are looking for. Okay, so now what you need to do now, because we are working with the time value for money, we need to calculate the amount that he's going to pay. That means the future value of 500 in 12 months. Ne? So now that means it is from this period to that period. Okay, so from here to that period, how much is going to be the time that it has accumulated? Okay, you are here 12 months and then it's 2 months. How much has your thing ran? So now it has ran from now to here, that is 2 months. Okay, and then from here to that is 12 months. So the whole time here, that means this thing has ran for 2 months already plus 12 months, which is going to make up the time of that investment to be 14. So that is one part. And then there's this one that if ever with reference to now, okay, with reference to now, you've got two periods. You've got this period to here, okay, starting from here and then from here to there. So now you've got 12 and then also you've got 12. So this one is starting here to here with reference to now. So now this is 4. Okay, so now this is 4. So now this investment, so it took this thing, it has ran already for 12 months and it's going to run again for another 12 months. So now you've got two payment, the length of the investment here, it is 12 plus 4, which is equal to 16. Okay, so with this one, this thing, it is from now to here, it is 2 months, and then again, it is running from now to 12 months, which is making it 14 months. So now you've got two periods here. So now for 500, you are going to have your simple interest is going to be equal to P into 1 plus RT. Okay, so now you want to get the accumulated amount for this period and that period. So now your present value there, it is 500 into 1 plus, you've got the same interest rate, okay, 0.11, and then your time, it is 2 months plus this one, okay, because now with reference to now, there is this period that you want to also take into consideration plus this one. So now this is going to be multiplied by 12 plus 2. It is going to be equal to 14. Remember here, you are working with the months. These are the months. So you need to divide that total period by 12. Okay, so now you are going to get the first amount there that is accumulated, which is going to be 564. 564.17. Okay, so you also need to take into consideration with reference to now, you've got this period plus it has also ran for that period. Okay, why there is a misconception here? The misconception of this question, it is based on that example whereby you are saying now you are making an investment at a certain period, and then it is ending at a specific period, whereby you are taking your final period, you minus the lower period. So now this one, you can easily make a confusion. Here, you've got a referencing point of the now. The now, something is happening ago. The now, something is happening in the future. That means you need to add those periods. You are not going to say 12 minus 4, because this thing is starting here, going forward. It is starting here, going to now. So there are two periods that you need to add. So we will do some more of these questions so then you can see where the time value for money takes place, whereby you've got now, when you've got the reference for now going backwards, and then you've got now going forward. So another accumulation is for the 700, which we said from 700 you've got 4 months to now, and then now to 12 months, which is going to make 16. So now you've got 700 into 1 plus, the rate is the same. Sometimes the rate will be different, but here the rate is the same. So you're going to have 0.11 multiplied by 16 over 12. Because we are working with months, we are making with months. So we divide by 12 months. So you're going to get that the accumulated amount is going to be 802.67. So you add these two, you add S1 and S2 to get your X. Okay, the amount that he's going to pay. So your X is going to be equal to 564.17 plus 802.67. Okay, so the final answer that you are going to get is going to be 13,000. Okay, it is 13,766, and you find that it is none of the alternatives above. Okay, so that's all that I have for you.